Hello, my dear Poynting lovers, and thank you, of course, for being here. It's time for us to bring some new and innovating stuff to our partners. Welcome to this webinar in which we will introduce our latest asset for the market. We strongly believe these new antennas will create a great opportunities for your connectivity challenges. The today presenters will be Mr. Hugo Carvalho, Mr. Birger Hiller, and me, Sofia Alexiou. Our today agenda will be the LPDA 500, the Omni 785. Then we will proceed to Heli antenna solution 31, 33, 40, and 51. Then we will talk about the Ripple 8 and the Ripple 16. And then we will finish with our new MIME 4 antenna. Okay. Before moving forward, allow me to introduce both myself and Poynting antennas. My name is Sofia Alexiou. I am Greek. I'm based in Greece, in Athens, and I am an electrical engineer. Before I joined Poynting, I worked for several multinational companies. I'd like to start for the very beginning. A lot of you attending our webinars today are already familiar with Poynting and its past. So let's start. By now, everyone sensed that we are interested in consistent wireless connectivity. But what makes us different? There are several important aspects in an antenna. Gain is important, and so is VSWR, for example. But there is nothing more important in an antenna than its radiation pattern. How predictable is the performance of the antenna? How stable is the connections the user will experience? Everyone will talk about profit. Everyone will be screaming about how high the gain is in your antenna, but not Poynting. Quality over quantity, especially in marine environment where ships are constantly moving. The antenna must have exactly the same performance in 360 degrees around you and being truly omnidirectional. Also at sea, vessel will pitch and roll, and it is necessary to control the vertical aperture of the antenna to keep the mast on land within the range. We develop, we create, we design, and manufacture our own antennas. Our R&D department, and of course, our patents comes from there. Furthermore, all that we saw in our datasets are actually measured antenna parameters and no results of computer simulations. The construction materials are carefully selected, both inside and outside of the antenna. And this makes Poynting antennas very resistant. Some of our antennas are E-marked, they have IP69K, IQ10, and they have plastic with UV protection and resistance to salinity. They are filled with foam or they have an anti-vandalism design. Our antennas are prepared for any environment and last several years. In addition to that, our DNA is to make Botman antennas electrically optimized to provide better electrical performance in each of its working frequency bands. But covering all this frequency, we guarantee that the 4 and 5G networks in the world are captured by our antennas. Finally, we design our antennas to have almost zero margin for error when we manufacture, transporting, deploying, and using them for a long period of time. This comes from exhaustive design for process and serious quality checks at every step of the design and manufacturing of the final products. This is the only way to ensure that each antenna is absolutely flawless. Okay, so I would like to introduce you our new LPDA 500 antenna. The LPDA 500 is a really big antenna. The LPDA 500 comes standard with a new improved mounting bracket, which can be rotated at 45 degrees intervals across all frequency bands with an 11 dBi peak gain. So this allows easy installation, and the customer will be able to mount multiple LPDA 500 antennas and orient them in a MIMO configuration, like vertically or horizontally, for or minus 45 degrees. Now, pointing antennas are well known for the design, and for future-proof antennas and the new LPDA 500s, it's no different at all. Okay. The antenna applications. Which are the antenna applications for the LPDA 500? We will talk about the main applications areas. Where we have water wells. Think how critical is the infrastructure to water wells. How important is to have connectivity in this kind of applications. And of course, houses, cottages in the mountains, where connectivity is always necessary. Of course, farming and agricultural and industrial and commercial for LTE and Wi-Fi deployments. Now, here we have the LPDA 500 selling points. The LPDA 500 is an ultra-wideband antenna, works from 617 to 7.2 megahertz. It's a leading program with a 5G. It has exceptional high gain performance over entire frequency range. It's a mainly ISO product, but can be converted by 2 MIMO by combining two LPDA 500s. Of course, Wi-Fi enabled with a gain of 11 dBi, and is ideal for failover of fiber outage cutters for LTE, 5G, and 5G. And of course, the unique innovative bracket that allows 45 degree installation terms. Okay. Which are the LPDA benefits and features? So, our new antenna, it has a really flexible installation. It's lightweight and has a rugged design. The narrow opening angle reduces noise. It's long reach, it has a high data throughput, supports latency, and it's really suitable for so many technologies like Wi-Fi, cellular, LoRa, helium, and more. Of course, it's future-proof, and it is strict even though it's big. And of course, it's deployable in any extreme weather condition. Here, we can also see the gain plots. We have, again, real measurements where we can verify, we can see here how really big is our antenna. Okay. So, it is the gain of the antenna. Okay, so here we have the mechanical data. The mechanical data, as we can see now how really big is the LPDA 500. The LPDA 500 is 1 meter and 382 centimeters in length. Everyone is uploaded in our website, so you are able to see all the data sets. Price and availability. The price for the LPDA 500, the MSRP price, it's 199 euros. It comes with master boxes. Each master box contains 4 antennas inside, and yes, we have it on stock. So we will proceed a little bit more. And I would like now to talk about our new Omni 785 antenna. The Omni 785 is an ideal for urban and rural application. It's an omnidirectional dual-band Wi-Fi antenna which ensures a strong Wi-Fi connection with improved transfer speeds for your router or modem. The antenna covers 2.4 gigahertz and 5 to 7.2 gigahertz Wi-Fi bands with a peak gain of 4 dBi across the bands. The antenna is ground-plane independent and can be fitted directly to any equipment that uses an RP-SMA connector. So this allows the antenna to be connected to any wireless access point, whether if it's an older Wi-Fi technology or dual band Wi-Fi technology. The antenna can be, of course, used to resolve channel saturation and provide the ultimate Wi-Fi performance and flexibility. The knuckle base of the antenna allows multiple angle deployments to accommodate the orientation of the equipment. So we will forward a little bit. And here we have the key selling points. The key selling points is a swivel antenna. It's directly mountable to the modem. It's a really small size. Improves slow or unstable data transmission, which is very, very important. It's a very good solution while traveling. It's ideal for indoor connectivity and, of course, increase system transmission reliability. Here we can see the measured results. We can see the frequency bands, the VSWR, and the peak gain. Again, and these are real measured results. Regarding price and availability, of course, we have it on stock. The MSRP price is 16.68 euros, and each master box contains 300 pieces. Now, we will move on to the next presenter, Mr. Hugo Carvalho. Thank you.
Hello. Thank you, Sophia. Let me start sharing my screen real quick. Okay, you should all be seeing my screen right now, and my mic is on. Okay, good morning, everyone. I hope you're all keeping well. I'll be talking about ELI antennas, even though I know most of you haven't done much with ELI antennas in the past. Our portfolio and the existing technological landscape, we're also kind of narrowing down the use cases and applications, and this means narrowing down the addressable market as well. But this is changing now. So even if you haven't done ELIs in the past, I mean, you haven't done projects with ELIs in the past, I would like you to keep your attention and stay attentive to the following minutes, where I hope to trigger you to think about the potential opportunities within your customer base. You might have some low-hanging fruit even in your contact list. We will address who these customers are, who these projects, what projects are these antennas built for. So keep an eye for it, because even though you haven't done it, you may do it in the future. So our ELI antennas, the applications for our ELI antennas are quite known of everyone. They're basically used in underground environments where the antennas make use of the walls of the tunnels as waveguides. They end up outperforming linearly polarized antennas and leaky feeders, and we're going to discuss a bit about that as well. Our customers have been using these antennas to ensure reliable connectivity systems in all sorts of mines, from coal to gold, in tunnel construction sites, and on very specific metro subway projects, amongst other use cases. Some of the most remarkable projects in Europe so far are a mining site in Iberia, where we have deployed where the system integrator has deployed over 2,000 ELI antennas, and the Istanbul metro, where one line is already operational and running on our antennas, where we're doing communication from the wayside, the tunnel itself, to the metro, and 3 more lines are going to be deployed and are being supplied as we speak. All in all, in our history, we have over 15,000 kilometers covered already, and we are pretty much sure this is just the beginning. Most of our ELI deployments have been done resorting to Wi-Fi frequencies, and a handful of applications also made use of LoRa or cellular frequencies. But in reality, indeed the big majority has been done using Wi-Fi. With all the buzz around 5G and private 5G, where companies like Ericsson and Nokia are leading the way, and with public 5G rollouts being done in a good pace as well, again with Nokia, Ericsson, and other manufacturers like Huawei, two new opportunities will make the demand for our yearly antennas to boom. The first one is, of course, public 5G infrastructure. Up till now, cellular deployments were done using leaky feeder, which is not fit for 5G or data-first technologies. The second one is private 5G underground networks for metros and subways across the globe, or any other tunnel or underground private communications applications, where again, leaky feeder is not a fit and linearly polarized antennas are not ideal either. The increase in private and public 5G deployments, together with the antennas I'm about to present, will crack open new business opportunities for you. Before moving forward, I want to give you some technical context to back some of the claims I just made, namely that there are shortcomings when considering leaky feeder and linear antennas to deploy private and public wireless communications underground, be it 5G, LTE, or even Wi-Fi. Firstly, regarding leaky feeders. To ensure higher IP throughput, channels need to be wider. For this to happen, higher frequencies need to be used, meaning deployments using frequencies over 1 gigahertz will become more common at these frequencies. At these frequencies, leaky feeder's performance is severely impacted as the attenuation behavior of the leaky feeder itself becomes too big. And this means that a lot of inline amplifiers are needed to keep the signal at acceptable levels. This adds to both cost and performance degradation. Also, leaky feeder offers limited and rather obsolete RF performance. There's no real MIMO when using leaky feeder because we can't get polarization diversity, and we get, even if we run two leaky feeders next to each other, we almost have no spatial diversity. Moreover, because leaky feeder sends signal 360 degrees around it, it creates interference, lowering the signal to noise ratio, or in carrier terms, carrier to interference ratio. And to achieve the higher throughputs that Wi-Fi 6E or 5G or LTE make possible, we need higher signal levels and better carrier to interference ratios. From both CAPEX and OPEX perspective, leaky feeder for higher frequencies is an absolute nightmare. How many hours do we need to install 5 kilometers of leaky feeder? How much do these hours cost, including manpower, associated costs like lifting platforms or health and safety costs? How many access points or radius do we need to deploy using such approach? And by using more active radio devices, how many switch ports, how many licenses for these switches and for the radios, how many power outlet points? And so adding more elements to the solution also means servicing these amplifiers and all the associated switches and power outlets. Not only that, and this is only from the deployment and operation, what if something goes wrong, and what if someone or something damages the leaky feeder? Then it takes longer to repair, there are longer service outages, and there's a higher cost, of course, to repair the infrastructure. Finally, leaky feeder is, of course, not as flexible, not as scalable as an antenna-based underground communication. Because with antennas, you can deploy the antenna, and as the tunnel increases, if you're still constructing or you're still building the tunnel, as the tunnel grows, you don't need to keep on running the leaky feeder. And this means antennas are actually easier to both to scale up and to scale down quickly to accommodate to changes, not only in the construction time of the tunnel, but also once it is in operation. With regards to the comparison between circularly polarized antennas and leaky feeder, and with circularly and linearly polarized antennas, there are also shortcomings when considering linearly polarized antennas. The first thing is, of course, linear polarization rotates unpredictably down a tunnel. This means there can be little to no signal for linear antennas on the end user device, laptop, smartphone, tablet, whatever, at certain point of the tunnel. LE antennas, on the other end, they contain all polarizations, therefore resulting in significantly more reliable connections. Linear polarization propagation varies greatly depending on tunnel dimensions and surfaces. And circular adapts better because it has all the polarization. So what I mean is when we're sending a linear polarized signal down the tunnel, it will bounce and be reflected and attenuated absolutely unpredictable. So there may be tunnels where at a given point or for that given tunnel, I have a better reception with vertically polarized when the signal is being transmitted with a vertically polarized antenna, and other tunnels where I get better reception if it's being transmitted with horizontal polarization. If I have a circularly polarized antenna transmitting the signals, I have all the polarizations there, so I will be sure to better adapt to whatever tunnel. I don't need to think and I don't need to test how the tunnel will perform for horizontal or for vertical polarized antennas. A bit on the same note, circular polarization propagates past obstacles and obstructions more reliably. Basically the same. Some polarizations at a given moment in time, and depending on the obstacles they face, train, cars, trucks, machines, they are going to block a given polarization, or they're going to attenuate it. When we talk about circularly polarized radio waves coming out of a circularly polarized antenna, this doesn't happen as much because, again, we have all the polarizations there. Then if we think about resilience and reliability, of course, and that's what it all comes down to, we can then add to the reliability of the system that's brought by circularly polarized antennas, antenna diversity techniques, both polarization and spatial diversity. Basically, if we use two circularly polarized antennas on one would be right-handed circular and the other one a left-hand circular, and we space them at least by one wavelength apart, ideally 3, as you know, we make sure that we get the full benefit of MIMO, both in terms of throughput. So this means that we can actually multiply the throughput from traditional systems, but also in terms of signal reliabilities, in the way that by having spatial diversity and indeed having spatial diversity, we will be fighting fading and improving the radio links capacity. Anyway, all in all, this will lead to, if you're deploying a wireless communication system underground using circularly polarized antennas, you will need less access points, less radios, or if you keep to the same number of access points and radios, you will create a system which is much more reliable, where throughputs are higher, latencies are lower, connection dropouts are lower as well. But these arguments need to be fine-tuned depending on who you're selling these to. I will address that later on. Let's move on from slide before you become hypnotized with those little circularly polarized animations. Now on to products. I'm going to talk to you about 2 new products, and for each new product that I'm going to talk about, I'm going to provide a bit of context by coming a step back and talking about a product that we have had in our portfolio already for 1 or 2 years for each of them. I'll start with something which is pretty much in line with what have had been our traditional ELIs, the ELI 31. Then I'll talk about the ELI 33, which is indeed the antenna we're introducing here, which adds a twist to our other ELIs, and that twist is something that unlocks these new business opportunities and potential for the range of ELIs. And then I'll move forward to the ELI 40 and the ELI 51. The ELI 31, as you can see from this slide, was already kind of the odd one out from the traditional ELI portfolio. While most ELIs cover Wi-Fi frequencies, the ELI 5, the 6, and the 31 don't aim at those frequencies, or at least only at those frequencies. The ELI 31 does Wi-Fi and much more. It covers every single frequency from 1700 to 7200 megahertz, and this makes it a very appealing antenna for dual band Wi-Fi deployments whenever the Wi-Fi access point has dual band concurrent connectors, and does so all the way up to Wi-Fi 6E. So this is also a differentiator in terms of frequencies comparing the ELI 31 to the other Wi-Fi Yilies, but it also covers a lot of the frequencies where both private and public 5G networks are going to be deployed. As you'd expect from an Yili antenna, is circularly polarized. This one in particular is unidirectional. You can get it in left hand and right hand polarization, and it's IP65 as the rest of the Yili, the mini Yili antennas. It's compatible with the mini Yili brackets, and this means that you'll be able to create a MIMO setup out of this SISO antenna using the brackets 45 and 47, which you can see to the left of our slide here. You'll be able to create a 2x2 MIMO solution. But if you use the bracket 46, which we also launched last year or 1 year and a half ago, you actually can create a MIMO 4x4 setup. Of course, these antennas that you see on the bracket 46 are not the Elite 31, they are the Elite 19, if I'm not mistaken. In terms of purpose and key selling points for this antenna, this Eli, again, it's an Eli antenna. It finds its space in mining and tunneling vertical, meaning that we expect it to be mainly deployed in mines, tunnels, whether they're being constructed or on operation, for metro or train tunnels, for road tunnels, again, for operation or service of those road tunnels. So if it's underground and needs wireless connectivity, this and on these frequencies, this will be a good product to solve it. From a technology standpoint, it will be used with any radio communications that happen to exist in the 1.7 to 7.2 gigahertz. Namely, the most known or well-known or mostly deployed technologies on these frequencies are dual-band Wi-Fi and private 5G networks. And I say private 5G networks, and here I'm not saying public 5G for this antenna in particular, because there are requirements from that in terms of power input, handling capacity, or in terms of low PIM for antennas that do public 5G and public 4G deployments. And this antenna is not really there. So that's why we have the ELI33 that I'm going to talk about in a few minutes. In terms of unique selling points, these are, of course, circularly polarized pointing antennas, so it is better prepared for data-first applications than leaky feeder or linearly polarized antennas. So this is the first argument, and I invite you to study. And if you want to know more, reach out to us on the differences between leaky feeder, linearly polarized antennas, and circularly polarized ones. But all in all, the technical differentiators will ensure better network coverage, leading to lower latencies, higher bandwidths, less connection drops, less access points needed, less points of failure, ultimately lower operating frustrations and better user experience. From the technical aspect of the technical aspect of this antenna, we have an antenna that covers the frequencies I mentioned already, with a VSWR that stays always under 2.0 and a peak gain of 9.5 dBi. After the 2100 megahertz, it's almost flat across the band. Here we have the radiation pattern of the antenna, no big surprises. Directional antenna with classic pointing, well-controlled radiation pattern. This one actually has a symmetrical beam. That's why we condensed on the representation the azimuth and the elevation radiation pattern of the antenna. And from a mechanical point of view, it's a bit longer than our traditional mini Heelys. And by traditional, I say the 11, the 12, or the pipes of the 13, the V2s, namely. So this one is 41 centimeters long, and the mini Heelys V2, they were 31 centimeters long. Regarding mounting options, again, as I said, you can mount them on the bracket 45, 46, 47, or just using an L bracket. The weight of this antenna is also a bit heavier than the mini Heelys. It weighs 1.2 kilos instead of 800 grams like the other mini Heelys. Like with any Heely antenna, made to order product, has a lead time of production lead time of 8 to 12 weeks, depending on how busy is production, on the availability of raw materials, how long will it take us to source them. They are manufactured in South Africa, always, our yearly antennas. And then transport time is between 2 to 10 weeks, depending if we're sea freighting them or air freighting them. And the MSRP is around 310 euros per antenna. So now on to the new antenna, the ELE33. This is still a prototype stage antenna, so this is not a ready product, a fully industrialized product. We're busy manufacturing more prototypes already that we're going to test in some POCs here in Europe as well in the next couple of months. In any case, the reason why we're coming out to you with this antenna is, and we don't want you to at any point be selling a PowerPoint, is because we have created prototypes already. We have tested those prototypes, and we are very, very happy with what we have seen. So we're very confident to let you know about this antenna and to allow you to go out there and start promoting it and starting creating the demand for it. We'll talk about how long it will take us to create prototypes, and so you'll have the full information with you. The ELE33 specifically targets the cellular frequencies. It will cover all the frequencies between 617 to 4200 megahertz. It has a power handling capacity of up to 50 watt, and it is low PIM specified. So this is it. This is why mainly this antenna is different from the 31. The frequencies it covers, starting at 600 and not at 1700. Together with the higher power input handling capacity and the low PIM specification, targets or puts this antenna as a suitable antenna for public 5G and public LTE underground deployments. This is cracking a new market for us as a company, but for you as well as a partner. Still on the antenna specification, it is a unidirectional antenna, IP65 like our other ELEs, and you'll be able to get it in left and right and polarized antennas to create those MIMO deployments that we talked about before. In terms of key selling points and its purpose, the 33 has some similarities with the 31. It also finds its space in the mining and tunneling vertical, meaning we expect it to be deployed in mines, in tunnels, road tunnels, train tunnels, metro tunnels, be it for construction or for operation or for servicing those tunnels, but now for servicing the users inside of these tunnels as well. So it can be just a regular road tunnel, and we're going to use this antenna to broadcast or provide coverage, 4G, 5G coverage along the tunnel. From a technology standpoint, it will be used to cover with any radio technology that exists between 600 and 4200 megahertz, and this means 2.4 gigahertz Wi-Fi can also be done with these antenna. LoRa can be done with this antenna, but we definitely see that the biggest market for this antenna is going to be public cellular, LTE or 5G, and private cellular, LTE or 5G as well. Basically, same selling arguments as the ELE31, just fine-tuned for a different market. All in all, what we need to be selling to our customers is better user experience, less frustrations, lower costs. Everything really is better when you're doing it with an ELE antenna underground. As I said, the antenna will be working up till at least 4.2 gigahertz, even though what you're seeing, the gain plot and the VSWR on my screen right now is only measured up to 3.8. And this was the case because when we first created the first prototype and we did the first preliminary technical sheet, this is all the customer asked us for, and we didn't need to unveil more than we actually needed to. But be assured that the antenna will perform up to 4.2 gigahertz, and this is very important for private 5G projects. Overall, a really nice antenna from our end, as you'd expect, below VSWR below 1.5, and the gain, which is hovering around 11 dBi, between 10 and 13 dBi more or less, with a peak gain of 13. Radiation pattern, no news, good news, pretty much controlled. Beaming the highest gain beams from the center of the antenna towards or from the center of the antenna towards the center of the antenna. Now, the reason why we still don't have a bracket for this antenna, or a good-looking bracket like the bracket 45 or the bracket 46 for this antenna, this is going to be much bigger than our other mini Heelys or the mini Heelys. This is not going to be a mini Heely. It's going to be the prototypes are 1 meter long and 20 centimeters thick or large. And we do have the ambition to create a bracket that will allow you to do a 2x2 and a 4x4 deployment, but there are a number of things that need to be taken into account. Especially, we want to design a bracket that's going to be suitable for metro or subway installations, train installations, and this particularity adds a number of requirements like the wind survivability, and the height from the ceiling, how far can you be from the ceiling. All in all, we're still busy designing this bracket. The weight of the antenna itself also adds to the complexity of designing it. It's a 1 meter long antenna, but 5 kilo heavy. So if you put two next to each other, then you have 10 kilos that are along 1 meter long. If you put four, then you have 20 kilos. So we're busy working on it. For the time being and for running the POCs, we have equipped the prototype antennas with the same mounting options as you get on a Heely 3. So it's still mountable today. You don't need to go to your to a local supplier to mount it. No, a pole will be good enough to mount this antenna, the prototype, and we are working on what will be the final design. This is a prototype stage product, as I said. It will take us 4 to 8 weeks to manufacture prototypes, and then regular lead transport times. The preliminary MSRP is 999 euros for the antenna. The bracket still doesn't have a price because we still don't have a bracket. How do they compare in terms of frequencies? One goes from 1700 to 7200 megahertz. The other one from 6117 to 4200 megahertz. In terms of peak gain, the 31 has a lower peak gain of 9.5 dBi, and the 33 has a peak gain of 13 dBi. VSWR control for both of them. Power input rating 30 watt for the Heely 31, so should cover all the private 5G deployments and private LTE deployments, and 50 watt on the Heely 33. In terms of low beam rating, the Heely 31 is not rated, and the Heely 33 is minus 150 dBc for 20 watt input and minus 47 for 40 watt in power input. This makes them fit for different technologies, right? So the 31 for private 4G and 5G and dual band Wi-Fi all the way up to Wi-Fi 6E, and the 33 for public 4G and 5G, but also for private 5G and private 4G, as well as Wi-Fi at 2.4. Time to talk about the Heely 40 and the Heely 51. First, the Heely 40, we launched this antenna sometime last year. Comes from our experience of doing multiple Wi-Fi projects. As I told you, a lot of our underground projects with the Heelys were on the Wi-Fi frequencies. And we came to realize that regardless of the great benefits that our users were experiencing by using a Heely antenna on the infrastructure side and a regular linearly polarized antenna on the end user device, meaning a phone or a tablet or a laptop, we realized that it was the performance was even better and bigger, in terms of reliability, if we were to connect circularly polarized access point with circularly polarized access point, like if we were to do a point-to-point link. So we wanted to bring this improvement in latency and in throughput to any vehicle or any moving thing that would be living and working inside of the tunnel. And this result in this, we can almost call it mobility antenna fit for underground applications. The LE40 is our first take at it. It's a 2x2 MIMO dual band antenna. They are, a lot of our projects are also done with using the two bands, so a 2x2 MIMO dual band antenna to ensure that we can cover both bands. Circularly polarized, and being MIMO, this means right hand circularly polarized and left hand circularly polarized. It's bidirectional, so it transmits to the front and to the back of the antenna, and it's a built for purpose antenna. So really it was built to be installed on vehicles, to be installed on mines and on tunnels where the environments are harsh and rugged. So IP69K, IK10, and because we were building an antenna for vehicles, there was really no need for us to reinvent the wheel. So we decided to stick with the design of the MIMO 3 and adapt it. So from the mechanical perspective, it looks like a MIMO 3. It works pretty much like a LE22, but of course in a much compact form, which has an impact on gain and radiation pattern as you would expect. All in all, same principle of operation. 4 connectors. These ones are SMA M and not N type like with the LE22, but 4 connectors, and then the antenna transmits the beams to its front and to its back. On the 2.4 gigahertz, a brilliant VSWR below 1.5. Yeah, I don't know where I wrote there. You're not, of course, seeing the results of the table on the top is regarding the LE31, but the images are actually correct. So the VSWR is below 1.5 for the LE40, and the gain, it has a peak gain of almost 5 dBi. I would say an average gain of 4 dBi. This one is correct, the table and the plots actually match the table. Again, a peak gain of 5 dBi, almost flat around 4, and a VSWR that stays below 2 for the better part. Here we have the radiation pattern of the antenna. No big surprise. Bidirectional antenna with classic pointing, well-controlled radiation pattern. From a mechanical perspective, if you have seen a MIMO 3, which I'm sure, and I know you did already, you know what to expect and what to count with, be it in terms of weight, size, be it in terms of mounting options, as well as accessories out of the box. In terms of lead time, regular point ELE antenna. In terms of price, this is it's priced at 447.75 euros MSRP. Again, as I said, the purpose of this antenna, and just kind of to summarize it and to wrap it up, the purpose of this antenna is to connect routers and access points and all kind of radios which live inside of a vehicle, machine, truck, rolling stock, whatever it is, which is traveling inside of the tunnel. But this antenna, and I've done this with Birger in the past, we've considered this antenna for other tunnel deployments, can be considered for tunnel deployments where the size and the shape of the regular LE22, for example, are not suitable because it's too big, or there's no space, or we want to have kind of this vandal-proof design that the ruggedness that the MIMO 3 shaped antenna brings. So it was designed for a vehicle indeed, but it may be considered for fixed locations if that's what you need at that point. As with respect to selling points, better connection between vehicle and infrastructure, lower latency, higher bandwidth, less connection drops, ultimately a better performance overall, with more stability on the connectivity. You can use, because this antenna is a bidirectional antenna, the radio, which is inside of the vehicle, as another point to your mesh network, if a mesh network is actually what you're deploying underground. So that's also a nice selling point for this antenna. And then dual polarization, dual band for the added redundancy and resilience of this antenna. And then, of course, all the technical discussion between linearly polarized antennas and vertically or circularly polarized antennas. To wrap it up, and because I'm pretty much sure you had enough of ELI antennas, I want to mention the last antenna, and this one is new, already a product, not a prototype. This is indeed already a product. And it's our second mobility antenna for the ELI series or the mining and tunneling application. This one is rather simple to explain now that you fully understand what the ELI 40 is, because it shares the same concept. A ELI antenna built and designed to be installed on a vehicle. The ELI 51 is a 2x2 5 gigahertz only antenna. So this is the first big difference between the two, between the 40 and the 51. And it is a unidirectional antenna instead of being a bidirectional antenna like the 40. Other than that, pretty straightforward, circularly polarized, left hand and right hand inside of the same enclosure. The mechanical aspects of it, it's pretty much the same thing as the MIMO 3 and as the ELI 40. And that's it in terms of brightness. Same thing with the ELI 51. It would be more or less the same thing as getting a couple of ELI 12s, adding them to a bracket 45 and deploying them. So what you end up getting is an antenna that sends two beams, one left-handed circularly polarized and one right-hand circularly polarized into a given direction. 5 gigahertz only, as I said before. Two connectors, SMAM, and that's pretty much it. A very good VSWR below 2, and again, that averages around 11 dBi, I would say, across the band with a peak of 14 dBi. So here you can see another difference between the 40 and the 51, namely for the 5 gigahertz, which is, of course, the frequencies that this antenna covers, a much higher gain. And of course, this has to do with the space we have inside of the antenna and what we could do, and the requirements, of course, that existed when we designed it. Unidirectional antenna, beaming to the front of the shark fin design. So when you're installing it, make sure that you're facing the narrower end of the antenna to where you want to see the beam coming from. In terms of mounting options and accessories, it's not as fully equipped as the ELI 40. It just comes out with the adhesive surface mount, and there's the optional magnetic base as well, but we sell the other accessories on the side. Price-wise, it's priced exactly at the same price point as the ELI 40, and availability-wise, it's same thing as ELI 31 or any other ELI. Made to order, 8 to 12 weeks to manufacture it, and then transport 2 to 10 weeks, depending on how we choose to go. The purpose of this antenna, pretty much in line with what the ELI 40 was, but it was designed for vehicles that go and work inside of that do work in underground environments. Big difference is, of course, this antenna is not bidirectional, but directional only. It has all the benefits from a circularly polarized antenna and a higher gain than the ELI 40. And these are basically the differences between the two. The frequencies that they cover, the gain that they have, and one being a directional and the other one being one is being a bidirectional and the other one being a unidirectional. A final word on the ELIs. We're working on a ELI antenna certification program to make sure our ELI antenna partners have a ground understanding of this line of products. And this will still take some time from us. So until then, feel free to come to us and discuss any projects you may have an eye on, any support you may need to prepare some outreach to your customers, to get more comfortable with the selling arguments and the technical aspects of the ELE antennas. And if you remember correctly, I said that you may have some even customers for this product on your customer base. And the customers who we believe would have an interest for these antennas are system integrators doing Wi-Fi, system integrators doing private 5G and LTE, and everyone is writing that buzzwords, private 5G, private LTE. So you'll know they are because probably they're quite loud about it at the time for the time being. Infrastructure installers, and this was a customer base that we were not addressing, or at least in a very active way. So people who are installing the base stations for the operators, namely, they are the same guys. The ones who do for the better part, they're the same guys. The ones that do tower installations, but also underground installations. So these guys, you can target them as well. MNOs and service providers, the operator itself. If we can tell them that they could be providing better service at a lower cost inside of the tunnels, I'm pretty much sure they will be willing to listen. Also, target whoever is selling, reselling, or installing, again, Wi-Fi or private 5G hardware or software. I know that private 5G and private LTE will, in a way, some manufacturers are opting for a classical channel distribution approach. So there will be people reselling this hardware. So it's a nice complement for whoever is selling that hardware. And finally, the end customers that are building, operating, or servicing any type of tunnel or internal vehicle or machine, from air quality to ventilation inside of the tunnels. A number of devices exist inside of the tunnels, and a lot of the times we are unaware of these, but they are there. As I said a few moments ago, besides the technical arguments, there are other sales arguments that can be used depending on who we're talking with. And I mentioned here a number of different types of companies. So if you want to prepare a meeting again, or a campaign, or to learn more about this, to address some of these clients, let's work together on it. While we don't have the certification in place, reach out to us, to anyone you within the company. You know, it's an open doors company. You can reach out to whoever will be more than willing to support with preparing for these meetings. And yeah, that's it from my end. Thank you very much. I see a Q&A popped up. We will address them by the end of the session, if you don't mind, if that's okay. Thank you very much.
So, thank you, Hugo. I will now start sharing my screen. So, thank you very much. Thank you, Sophia, and thank you, Hugo, for presenting some fantastic new products, which will open a lot of opportunities for our partners and their customers, of course. Now, I'm happy to talk about, I think, the product with the coolest name, being Ripple. And you see Ripple 8, Ripple 16, which, of course, is an antenna that we've constructed, made for our maritime partners and their customers. So, in short, a little bit, the maritime antennas, last 4 years, we sold about more than 15,000 maritime antennas. But it even goes back further, because our first antenna, maritime antenna, only was created in 2016. That was the Omni 291. But before that time, our antennas were already installed on vessels everywhere in the world. We sometimes still discover Omni 69s on vessels that are still alive. So great, even when they were not seaworthy, as we would say. So starting from the Omni 291 in 2016, we've of course implemented all the necessary parameters to be seaworthy, like IP68, UV, salt waterproof, etc. Those things you need on a vessel, of course. So the Ripple positioning, you see the very nice shape and design of the ripple. So where do we position the ripple? Of course, it was the missing link between the already existing product range on maritime antennas we have, and we do have quite some antennas there, which all have different applications, of course, or same applications. Now, about 2 years ago, we've presented our prototype Wave Hunter, which is already out there and performing really well. We get really nice feedback and results on that. Now, the idea about the dome solution in maritime world is, of course, increasing system reliability on transmission, enhanced LTE and 5G reception, which is, of course, more and more crucial as we see more and more connectivity challenges and demand for higher bandwidth. It's, of course, created for harsh environments because we all know that the sea is not forgiving. So it's very harsh environments, salt, UV, water. It can be quite stormy out there. So it needs to be really protected against these environments. And of course, there are different marine applications. We can go for super yachts, commercial vessels, cruise ships, ferries, expedition yachts, offshore vessels, even buoys. And then we should think about not the small red round things floating in the sea, but you have these buoys that have cameras on there. They monitor every changes in wind speeds, storm, also security cameras for offshore wind farms, for example, harbor buildings. So everywhere where there's demand of higher bandwidth, it is applicable. So why ripple? Yeah, of course, what we have seen also in the maritime market, that there's more and more demand for higher bandwidth. A nice catalyst for this was, of course, COVID, where we saw that people had to stay on the vessels for very long times, missing friends, family, etc. So that's one thing where IMO, the International Maritime Organization, decided to create a maritime law that a minimal internet should be available for the crew, the crew welfare. So that really is a catalyst. So people are really looking at more resilient, more stable, and higher bandwidth solutions on 4G, 5G, and other solutions, of course. So we create bandwidth and a higher bandwidth solution within an IP65 enclosure, of course. Flexible solution on cable management, because we all seen the introduction from 4G, from 5G. We went the evolution from 4G to 5G. And this, of course, meant from going from 2 antennas to 4 antennas. Now imagine that what I've seen from the last year's installations, that more and more of these standard installations go to dual 5G, 5G meaning 4 antennas, dual 5G meaning 8 antennas. Imagine pulling cables over 10 to 15 meters, but then times 8. It's not only expensive, but also very time consuming. And of course, we all know that long coaxial cables will induce more loss than, of course, short coaxial cables. So we also, one of the key selling points is that it's high bandwidth within a budget-friendly solution, which means it will cost money, but the total solution will not be that more expensive. We have some comparison charts on normal antennas with cables, time consuming, and a ripple with all the antennas inside. So we are happy to discuss that. We're, of course, brand agnostic. That means you can set up any kind of brand or router combination inside the ripple, which, of course, makes it all, again, a lot more flexible because, well, you can really combine every kind of router, because per application you can have a separate or a different combination of routers inside, of course, depending on the application. Now, what of course we do, we combine our patented superior radiation patterns. It came up in the presentation of Sophia and Hugo. It's something you now expect from us, that we shape patterns, radiation patterns, because those really give a clear view on how the antenna will focus its energy and where that fantastic gain you see sometimes is really going to, because you need to know what is this antenna doing. Now, of course, we are here talking about a maritime antenna, an antenna that will go on a moving object, meaning a vessel. Well, of course, here we have the benefit of really being experienced and creating a really consistent omnidirectional radiation pattern, which has a really even gain in a 360-degree view, which is very important on a moving object. And what we've, of course, implemented out of our vast on-land experience, and also the experience we have from WaveHunter, is the effect of cross-polarization. Cross-polarization is really a technique that anticipates on what happens out there when the electromagnetic waves are traveling from the cell tower towards the receiving object, in this case, the vessel. So it's a technique we use to double the bandwidth. And that's really a quote from, I could quote our CEO: the moment you're 3 kilometers from the cell tower, this will double your bandwidth compared to a normal vertically polarized or horizontal polarized stick antenna. So that's really simple technique we apply, patented of course, to double the bandwidth of the signal using the signal that's out there. So we have electrical features. So we are talking about peak gains of 2 different setups, because why? We offer a 4 times 4x4 MIMO, so you can really have 4 5G modems in there. We have 8 vertical and 8 horizontal antennas. Yeah. So we have the cross polarization. Ripple 8 will have half of the antennas. Ripple 16, the 4x4, the 4 times 4x4. Ripple 8, the 2 times 4x4. Cross polarization will increase signal reliability and double data rate due to the full MIMO performance. That's what we already discussed. Covers the contemporary 5G LTE bands from 617, the band 71, which is already used in US and South America, and will probably come to the rest of the world too, up to 7,200 megahertz, and then we're talking Wi-Fi 6E. It has 2 GPSs inside, GLONASS Galileo, so we'll work with the 3 different systems. And of course, it has a high performance, and this is the difference between WaveHunter and Ripple. Here we use omnidirectional antennas to create the array inside the Ripple. And it's of course marine and coastal. We have of course 2 different peak gains, as you see. The vertical antennas do have 9.5 dBis of gain, and the horizontals will have 3 dBis of gain. So mechanical features, of course, it's UV and salt waterproof, else you don't have any business on a vessel. And it's protected from marine and coastal conditions, so it should protect those routers inside very well. It is IP65, weather dust resistant enclosure, and it has a very innovative heat sink that is designed to really improve the temperature regulation inside. As we all know that 5G modems will produce a little bit more heat than 4G modems. And it also has wind survival up to plus minus 186 kilometers, which is quite a storm, I guess. So Ripple 16 and thus also Ripple 8, it's a circular array of omnidirectional antennas that operates in the following frequency bands. Here in the picture, you can see 617 to 960 megahertz, 1427 to 1517, 7010 to 2700, and then 3400 up to 6000 megahertz, and the 4 times dual band Wi-Fi up to Wi-Fi 6E, meaning 7200 megahertz. And of course, it's always nice to see Ripple measured results in the comparison to a lot of brands, also really renowned brands. We do measure our results. Everything you see in our technical documents are measured results and not simulated results. And this is something we see a lot, but it is very hard to compare simulated results in real life. So we give measured results and honest results. What you see is what you get. So you see the Ripple here inside, you see a router compartment where you can fit in the routers. So to our radiation patterns, again, what you see always what you need to look at is VSWR on a certain frequency and the gain, of course. That's where you need to look. What does this antenna mean for my application? What we always say, try to keep the VSWR below 2.5, better 2 or less. So you can really see that it's almost 95% below 2, which is awesome. And the gain on the vertical, we are here talking about the vertical antennas. You can see it's really consistent, and it's a peak gain of about 9.5. And depending on the frequency, of course, but I should not explain, there can be a difference, which is normal. Cellular horizontal VSWR, again, you see 95% below 2, which is awesome again. And then the 3 dBi max gain on the horizontal antennas, as we mentioned, you can also see in the gain graph. Then the radiation patterns looking azimuth. This is what you should expect from Poynting, which we are really great in shaping those radiation patterns. And as we're talking about moving objects, of course, the omnidirectionality is really key. And this is something we are really good at. You can just see it. The outer circle is the max gain that we put in our spec sheets, but you see that this radiation pattern shows that you're really close the whole time when you look at the 360 view to our max gain that we describe in the technical sheet. Really consistent signal reception, which will give, of course, the router a really consistent signal to work with and do all its features. On the elevation part, this is, of course, something we've been explaining in our maritime webinars also. It is very good to have a very nice vertical aperture on a maritime antenna. Why? Well, the sea is practically never a mirror, so there will always be some kind of waves. So a very nice vertical aperture will avoid you shooting over and under the cell tower with your antenna when there are quite some waves at sea. And when you go too high a bandwidth, your vertical aperture will be very narrow. And the moment the smallest wave hits your vessel, you will shoot over and under the cell tower. So you need to avoid it. But you see here in our antennas, a very nice vertical aperture. So azimuth on the horizontal, again, very nice, consistent omnidirectional, as you see. And then going to the elevation, again, very nice elevation, vertical aperture, which will keep that consistent connection with the cell towers, even when it gets a little bit more rough out at sea. So ripple mounting options, it's a surface mounting antenna, but most integrators that work in the maritime world, of course, know that how they can install it, probably somewhere on a pedestal, already existing pedestal of an old VSAT, or maybe a new one they create in a local metal shop in the harbor, or to put the ripple on there. You see maybe the height, so it's about 41 centimeters in diameter, so it's not that big. And it's almost 50 centimeters high. So it's quite small for a dome solution on a vessel, if you compare it to the bigger VSATs, etc. Here a little bit the comparison, the key features between Ripple and WaveHunter. And I must say we are having a maritime webinar on this Thursday, will be done by Hugo. Where we go more in depth on the differences here, and this will really explain more when to choose what. And I hope you can follow that too, because we really share some valuable information on this. Now, going over this Ripple 16, whether it's 18 or Ripple 8 or 16, compared to WaveHunter, what you see, Ripple 16 has 8 vertical ports, 8 vertical antennas, and 8 horizontal ports or antennas. Compared to, of course, where we work with WaveHunter is in 6 sectors with 4 polarizations, vertical, horizontal, plus and minus 45. MIMO, it's a 4 times the possibility of the 4 times 4x4 MIMO setup. So you can combine a maximum of 4 5G modems in there. And on Wi-Fi, you also have 4x4 MIMO Wi-Fi. Ripple, of course, has 6 times 4x4 LTE. The frequency bands 617 to 4200. The Wi-Fi 2.4, 5.6, and 7.2. And of course, GPS is in there too. Those frequencies are known. And then the same frequencies for Wave Hunter. So there's no difference there. Those frequencies are covered. Polarization with the Ripple is vertical, horizontal. And in Wave Hunter, we have 4 polarizations. The peak gain, there you see the biggest difference. You have 9.5 dBi max gain on the vertical antennas and 3 dBi on the horizontal, where you have 11 dBi on the Wave Hunter antennas, the max gain. Connector types, we've introduced right angle SMA and right angle RP SMA for the Wi-Fi. So in total, there will be 18 normal SMAs and 4 RP SMAs. So we've introduced right angle. Why? We've had very valuable feedback from the system integrators that it would be more practical to have right angle. So we implemented that. And of course, we implement all the cables through the coaxial cables. And this is where it's really a difference, because this is such a time saver. Imagine an integrator crimping cables at length and then times what you see here is 22, and then needing to crimp them, put the connectors on there, sizing them, and then still installing them on a vessel, running them through cable glands. So you cannot imagine how much hours you lose on doing this. So it's a real time saver. The cables are just in there, you connect them to the modems, and done deal. The same, of course, with Wave Hunter, where we've evolved. The V2 version didn't have any cables yet. Starting from the V3 version, we've implemented the 30 cables inside, so you can simply connect it to the routers. No more cable measuring or crimping of connectors. It's all in there. Mounting options, both are surface mount or on a pedestal. Weight and dimensions, this is also a big difference, of course. You see the 51 kilograms of the Wave Hunter, and you see the 15.44 kilograms of Ripple, which means that, let's say you have 2 people installing it, you could easily get this up there without a crane. It's only 15 kilograms. And then maybe another guy hold it down when you screw it on there. But it's really flexible, and you do not need a crane to put it on the vessel. Packaged weights, of course, and the EN codes will all be in this technical sheets, so you will be able to implement it in your systems. So, big difference, Ripple Wave Hunter. This is something which will be explained much more in depth about Hugo this Thursday. So, of course, in a Ripple, you can combine 4 5G modems, and in a Wave Hunter, you will have 6 5G modems. That means you can combine, you aggregate the bandwidth of 4 5G modems compared to 6 5G modems. There you can make a difference in bandwidth, of course. The Wave Hunter will reach further because of its higher gain, of course. It uses directional antennas with higher gain than the omnidirectional antennas that are in Ripple. Wave Hunter also has a superior signal to noise ratio. Why? Of course, it is inherent to the use of a directional antenna that it only looks in one direction, so it could only catch noise from one direction. And compared to an omnidirectional antenna, which looks 360 degrees, it can, of course, see noise from everywhere. So Wave Hunter will have a better signal to noise ratio because of the directional antennas inside. And then Ripple at 8 or 16 is much more budget friendly, and this is where we really had a very good feedback at SMM Hamburg in September 2022, the biggest commercial maritime show in Europe, probably in the world, where the integrators really said, okay, we can work with that, with this price point and the time saving, and of course the quality of the product. We can really work with this in the commercial maritime market. And we also had this feedback from shipping companies that it's really acceptable for this solution to have it. The Ripple is available in the following configuration. Of course, the Ripple 8 where you can implement 2 5G modems, Ripple 16, where you can implement 4 5G modems. MSRPs, Ripple 8 will be 3,999 and the Ripple 16, 4,999. The lead time, we will have around, what, 20 to 30, I must say. We had a meeting on this, 20 to 30 units coming in and mid-end of June 2023, so in 3 months. Pre-orders are recommended if you would already have people interested or implementing this in project tenders or whatever. Be fast, and we will have about 70% of that will be Ripple 8, and then the rest will be Ripple 16. So be responsible, take stock, take pre-orders, because these things are made to order, and we will try to have some stock in Europe, but we've seen the reaction at SMM, we've seen the feedback in the market. These things will go fast. I think we're dropping the bomb here with this product in the commercial shipping market. So yeah, reach out to your customers and make sure that they have availability on the Ripple. So that's all from my point. Thank you.
Thank you, Birger. Okay. Hello again. I suppose that everybody sees my screen. I would like to introduce you our new MIMO 4 antenna. So, why we developed this model? Our customers required more, and we always listen our customers. The MIMO 4 is up to 9-in-1 high-performance multi-frequency antenna with a single housing. The antenna provides 4 cellular, 4 Wi-Fi, and GPS antenna. The 4 cellular MIMO antennas offer wideband covering LTE, 4G, and 5G bands up to 6 dBi gain. The ultra wideband performance of the cellular antennas allows it to be used across different operators and technologies. The MIMO 4, of course, is available in 2 colors, white and black. Here we have the MIMO 4 key selling points. As I told before, it's up to 9-in-1 performance in a multi-frequency. It's a multi-frequency antenna. It's a 4x2 MIMO LTE 5G, 4x4 MIMO Wi-Fi, and GPS. It's ideal for transportation and marine implementation. It's also ideal for critical Internet of Things applications, and it has a multi-mounting option for easy installation. We will talk about that a little bit later. Here we have the mechanical features. We pay attention to details which are invisible to our customer, but causes failures much later. That's why you need a reputable manufacturer. Our new MIMO 4 is designed for rust and it's designed for rust and corruption. It's has a salt. It's designed for salt water spray. It's water protected to avoid rust and corruption. Also, it comes with a UV protection to ensure does not become brittle, and it has a high quality design materials and manufacturing. Of course, it has IP69K and designed to withstand wind speeds up to 160 km per hour. For water resistant for an IP69K enclosure. Now, here we have the frequency range. The MIMO 4 works from 617 to 6,000 megahertz, and the Wi-Fi frequency bands from 2.4 to 7.2 megahertz. So we can save more time online for everyone on board. We will proceed a little bit more, and we will see now what are the differences. Let's talk about the main differences and start with PAC vs MIMO 4. Here we have three main differences. First of all, we have differences regarding the frequency band. The PAC frequency bands are from 617 to 4.2 megahertz instead of MIMO 4, which are 617 up to 7.2 megahertz. Also, the PACs come with a standard 2x2 MIMO 5G and 2x2 MIMO Wi-Fi and 1 GPS, instead of MIMO 4, where we have more options. We have 2x2 or 4x2 MIMO 5G and 2x2 or 4x4 MIMO Wi-Fi and 1 GPS. And of course, here you can see that MIMO 4 has bigger diameter regarding the PAC antenna. And it's very, very important to say that MIMO 4 beats the same size competitors. We will move on and see what are the differences between MIMO 4 and MIMO 3. Again, the most important thing are the frequency bands. The MIMO 3 frequency bands are 410 to 3.8 megahertz instead of MIMO 4, which are 617 to 7.2 megahertz. So MIMO 4 comes with more options regarding MIMO 3. MIMO 3 comes with 2x2 or 4x4 MIMO 5G, and it's standard with 2x2 MIMO Wi-Fi and 1 GPS. And the last, and of course, the last thing, MIMO 3 has a bigger height instead of the MIMO 4. We will see that a little bit later. Here we have the antenna applications. There are so many applications, so many verticals. We can use the MIMO 4, of course, in marine, mobility, big trucks, for big trucks, buses, machine-to-machine, urban and rural, farming and agricultural and industrial applications. Again, we have always measured results. Here we can see the cellular measured results, which are indeed have an excellent performance. Here we have also the measured radiation patterns, the cellular measure radiation patterns, and the MIMO 4 exceeds the performance of the most competitors due the attention to the design of this high-performance antenna. The radiation patterns of all radiating elements provides an excellent balance between omnidirectionality, pattern diversity, and good radiation abilities at the desired elevation. This is very important, especially for the transportation and marine market. Here we have again the measure results. Here we can see the Wi-Fi results, frequency bands, VSWR, and peak gain in band, which are also excellent results. Here we have the measured radiation patterns for the Wi-Fi, where we can see at the azimuth plane that we have a constant omni pattern across all frequency bands. We will forward a little bit more, and here we have the mechanical data. Everything is already uploaded to our website, so you can download it and see what are all the data sets for the MIMO 4 series. The antenna height for the MIMO 4 is 64.89 millimeters, and the diameter is 160 millimeters. So we compare before the MIMO 4 with MIMO 3 and PAC. We can say then this is true, so it's smaller than MIMO 3 on height and bigger than PAC regarding the diameter. Here we have the mounting options, which is very interesting and very important for you and your customers. Poynting MIMO 4 antenna arrays provide an easy installation with a multiple mounting options. We include a standard, a vertical and horizontal pole, wall bolt, marine mount, surface mount, double-sided, and a spigot. And of course, we have a magnetic mount, which is optional. Price and availability. We have 3 different MIMO 4 product codes and also the color option. The MIMO, so we have the MIMO 15 and the MSRP price is 195 euros. It comes, of course, in master boxes in 8 pieces, and the availability will be in June, this May and June. We have the MIMO 17, the price is 245 euros. MIMO 19, the MSRP price is 295 euros. And as I told before, each master box has 8 pieces of MIMO 4. So you are able to pre-order now because we expect stock until May or June. Also, it's very important to say that the MSRP price for the magnetic mount is 45 euros, and we're expecting also these mounting options until May and June. I would like to thank you very much for your attention. You will receive this presentation and the marketing materials during tomorrow. Thank you all. We hope you found the presentation informative and useful. Now we would like to open the floor for questions. Please feel free to ask any questions you may have about the topics we covered in today's webinar. We will do our best to provide you with helpful and innovative answers. To ask a question, simply just type in the Q&A box, and between Hugo and Birger, we will address it. Thank you very much.
Thank you, Sophia. We have been answering some of the questions myself and Birger already. Question: what's the application for a 9-in-1 antenna? Well, it's to follow the market demand and more routers being installed on board. All in all, it's a 9-in-1 is a 4x4 cellular, 4x4 Wi-Fi, and 1 GPS. It's going to be a big volume item for us. I don't think so. So that's it. Second question. I think probably you can answer this one, Birger. I'm not 100% aware of it. Will the new Ripple have cable kit options, SMA or QMA? It comes packing SMAs, right?
Yeah,
and I think
it will have right angle SMA. We will, of course, we already have QMA adapters, and we are investigating the opportunity of having separate cable sets, because we know that there will be different combinations with routers having QMA and not QMA as normal SMA. So we're investigating as separate cable sets if it will be necessary to deploy them. So, but this is already something we are dealing with for Wave Hunter, and we know that there will be in the Wave Hunter will be more QMA available than normally in a Ripple, where you have most routers will have SMA. But we're looking at that, so we will confirm that when the case is there.
Yeah, I think that's all. Petros, yes, let's set up a meeting. Let's discuss. You wrote that you'd like to meet to discuss some ELE solutions and how have we been seeing the market and the options right there. Yeah, let's set up a meeting, not today, but we will do it this week for sure. So thank you for that. Just I'll send you an email to set it up. And that's pretty much it. Sophia said thank you already from my end, and thank you as well. Quite a big one today, but we had a lot of antennas that cover different verticals, so we decided to squeeze them in all together. Hope you well, we have another question still.
Wait a minute. Yeah.
Yeah. Question as well, Birgit. I think you can answer this one as well. Regarding placing the Peplink HD4 MBX inside of the repo on the newer versions or the V1. Some of you may be aware we had some pre-production units of the repo. The V0, we were selling them to very specific maritime specific partners, and that one had some I'll say it, imperfections on the mounting options for accommodating this Peplink router. But I think this is solved, right, Birger, in the V1.
Yeah, and in the
V1
final
version.
versions, this is why we needed the valuable feedback. So this will be solved. Yeah.
Yeah. Good. Yes, I think you will get the PowerPoint, the PDF of the presentation. We will there will be a link to
Recording.
Francisca is typing the answer, so she knows what she's going to send afterwards. I think so.
Looking at other stuff, no.
No, that's all good. I think we can call it a day.
Thank you, Justin.
Thank you, Justin. Thank you, everyone, for attending. Lovely to see the great turn up. And yeah, let's keep in touch. Thank you very much.
Thank you.
Thank you, guys. Well done.
Thank you, Peter.